continuing with the law of sines. There are some rules to the law of sines that allows you to be able to find the area of a triangle, not just the length of the side. So if we go back to our page right here, everybody, very important that you guys write these formulas down in your journal. They're not necessarily easy to remember, but there is a pattern. Okay? So what we're going to do before we start our problem number 5, let's go ahead and zoom in and let's look at the pattern. See if we can see it. Okay? Zoom out just a bit. There we go. So right here, I want you to look at this formula, and the last one. What do they all have in common? What do all these lowercase letters represent? If you see a lowercase letter, what does that represent? Side, right? What do all the capital letters represent? Angles. Notice, you have lowercase b and lowercase c, but you need what? Capital A. Here you have A and C, but what do you need? You need capital B. And the last one you have A and B, but you need capital C. So basically, here's the pattern. Whichever angle that you have, you want to make sure you have the sides that are not across from the angle. All right? So if I were to draw this picture right here, I'm just going to draw a random triangle to represent this part right here. If I say, ooh, I have angle A, well, guess what we don't need? We don't need the side that's across from it. What do we need? We need this side right here, and we need the other side. Just think about right now, in the formula, you need the two sides, and you need the measure of the included angle. All right? So, by the way, back in geometry, when you were learning about proofs, all right? Think about this. This is a side, this is an angle, this is a side. So basically you need a side angle side in order to do these formulas. Okay, that's what you're looking for. You need a side angle side. So right now, how many sides do you need? You need 2 sides and 1 angle. And the angle that you need is going to be what's called the included angle, because it's included in between the 2 sides. Okay, so if you don't remember the formula, remember that you do need the angle that's included between the sides. This formula is a little bit different. What do you notice? How many sides do we have here in the formulas? 1. How many angles do you need? All 3. So if you're going to use the area of a triangle, by the way, K, guys, represents area, just so you know. So when you see the formula K, that means the area of a triangle. Here, you just need 1 side. But you need how many angles? You need all 3 angles. So you need 1 side and 3 angles. So what I'm going to do is we're going to look at this problem. Not that. Oh, there. All right. Now, when you guys are used to solving for the area of a triangle, what's the formula that you're used to using back in like just your basic geometry? Base times height divided by 2, or sometimes people say 1/2 the base times the height. So how about this? Since I put it on grid paper, I put our triangle on grid paper, you can easily see that the distance from right here to here is how many units? 4. So what would our base be for our triangle that we could use? 4. So right now let's just find an estimated area, okay? Not the exact area, but an estimated area. So the area is 1/2. I'm going to put 4. Now, the height is from the bottom going straight up. What would you guys estimate the height to be? Because it's not at a 2, is it? It's slightly what? Slightly more. So what would you guys think that would be? 2.3? Let's put 2.3. So in the calculator right now, just do 1/2, 4 times 2.3, and see what you guys come up with. 1/2, 4 times 2.3. What do you get? 4.6. So if we just drew the picture, we get 4.6 units squared. And this would be the estimated area. What are we confident about? We're confident about the base, right? What are we not confident about? The height. So what we're going to do is we're going to use one of our formulas that we just talked about right over here. One of those. All right? Let's think about it. How many angles do we have? All three. How many sides do we have? One. So which one are we going to use? Door number 1, door number 2, door number 3. Door number 3 is correct. Can you guys see this right here? Write that down. Oh, no. I'm going to write K, which represents the area, equals 1/2. I'm going to open up a parentheses. I'm going to put C squared. And then I'm going to put the sine of what? What's the formula say? The sine of, you guys have a number? Sine of A, there we go. The sine of B all over the sine of C. Now look at the pattern here. What letter do we have? We have lowercase c. What angle's in the denominator? The sine of capital C. So if you guys go back to the formula, check this out. I want you guys to see a quick little pattern. Here, you need A, and the sine of A is in the denominator. Here, B, sine of B in the denominator. The one we're using is C, sine of C in the denominator. So now what we're going to do is we're going to plug in our numbers. So I'm going to write equals 1/2. What number are we plugging in for C? The lowercase c, everybody, we're plugging in a 4. Then I'm going to say in the numerator, the sine of A. Well, by the way, wait a second. What is angle? Oh, there's A. There's B. So the sine of A is the sine of 37, the sine of 69, and that's all over the sine of 74. Now this might look a little tricky to plug into a calculator, but we're going to do it together in the calculator. All right? So turn on your calculators. I'm going to clear everything out. I'm going to do 1/2, open parentheses, 4, close parentheses, squared. Then I'm going to open up another parentheses, and this is the most important step. Okay, alpha y equals enter. Alpha y equals enter. It makes it a lot easier now that you can put everything on top. So we're going to get the sine of 37, close the parentheses, sine of 69, close the parentheses, and then go down and type in the sine of 74, close the parentheses. And then I'm going to close the parentheses right over here at the left. So at this point, everybody should have this in the calculator. If you need to see that again, just rewind me, mute me, and watch it again. Then you press what? Press enter. Holy cow, Adam. Look at that. What did we get? 4 point. That was right from the nearest 10%, but 4.7 units squared. What was our estimated area? What was our estimated area? 4.6 units squared. We got pretty close, didn't we? All right. So our actual, a better approximate value is 4.7 units squared. Now, why did I draw this out on grid paper and do the estimated part first? I wanted you to see that when we actually did the actual formula, that your answers come really close to your approximated value. Okay? So what we're doing today, everybody, what we're doing today is you're looking at all of your formulas, okay? And I say all of your formulas. You're looking at all of these and ask yourself this: what do you have and what do you need? You're either going to use one of the formulas up here, or you're going to use one of the formulas down here. Okay? And if you need help typing it in, feel free to ask. Well, not if you're watching the videos.